Amazon has completed a mass timber warehouse in Indiana, USA, which the company says will be used as a test bed for over 40 sustainability strategies to implement in existing and future buildings. Located in Elkhart, the DII-5 warehouse is primarily made of mass timber and was designed by design architect ZGF Architects with elements such as clerestory windows, circadian lighting, and EV charging stations as part of the company's goal of reaching net zero operations by 2024. According to the company, the building is the first large-scale owner-occupied mass timber logistics facility in the United States, and the project is aiming to achieve Living Futures Zero Carbon certification. The building joins others that Amazon has used mass timber to build, including its HQ2 buildings in Arlington, Virginia. The company notes several of its buildings have achieved Living Futures Zero Carbon certification, including warehouses in Australia and one in the UK. From the moment you approach and enter Amazon's new delivery station in Elkhart, Indiana, you know you're somewhere special. First, there's the wood that makes up much of the walls and the ceiling. Then, there are the windows, vast expanses of glass that bathe the interior in sunshine. Oh, and the more than 170 electric vehicle charging stalls just outside. This is indeed a new kind of delivery station. And those elements that are obvious at a glance are just a few of the ways Amazon is powering another effort central to its future. DII-5, as Amazon calls it, is not just the delivery station. It doubles as an exercise in sustainability, packed with more than 40 market-ready technologies and systems designed to reduce its resource usage and shrink its carbon footprint. Amazon has designed its new delivery station to help reduce its carbon footprint as well as its resource usage across its global network of buildings. And it's not just meant to make a difference in Elkhart. Amazon is counting on DII-5 to give vital data on how those sustainability initiatives work in its facilities. The goal is to find out which offer the right balance of cost and performance, and which Amazon might be able to scale across its global operations, taking their impact way beyond one building. DII-5's wooden walls, which are made from over 500,000 board feet of southern yellow pine and sit atop a foundation of lower carbon concrete, are made of a material called mass timber, or engineered wood. It's a material we've been using for years, including at our HQ2 in Arlington, Virginia, and one we're working to implement at a larger scale. Mass timber is made by combining pieces of softwood trees like spruce, fir, and pine, the kind of lumber you can buy at your local hardware store. Those pieces are glued or laminated together, resulting in a material that can hold its own in terms of structural strength, is less carbon intensive to produce, and locks in the carbon that the trees sequestered before they were harvested. Trees absorb carbon from the atmosphere, store it in the cells of their fiber. If we can lock up that material in the building for 50 to 100 years, we're creating a carbon bank that keeps that sequestered carbon from being re-released into the atmosphere. The net effect is that going with mass timber can put a serious dent in a building's carbon footprint. A 2022 study found that on average, the embodied greenhouse gas emissions of buildings made of reinforced concrete are 43% higher than those of mass timber structures. The game-changing part around mass timber is that it's taking a ready commodity and turning it into this structural element that can replace much of the concrete and steel that goes into a building. Before mass timber, we didn't have a market-ready bio-based structural solution that was competitive with concrete and steel. DII-5 challenges the idea of what a logistics facility can be, says Marty Brennan, principal at ZGF Architects. Amazon's scale and commitment to sustainability allowed us to push boundaries with our design, bringing together numerous partners from across the building industry to create a welcoming experience of light, wood, and native prairies that nurture Amazon associates, delivery service partners, and local wildlife. We have experimented with and implemented a lot of sustainability initiatives over the years, says Daniel Mallory, Amazon's Vice President of Global Realty. DII5 continues that effort by taking a culmination of a lot of big ideas, not just in how we operate our facilities, but in how we build them. And it's going to help us as we steadily climb toward our sustainability goals. Globally, buildings and construction account for 40% of greenhouse gas emissions, according to the Carbon Leadership Forum. As Amazon works to meet its climate pledge commitment to operate more efficiently and sustainably and to decarbonize its entire global operations by 2040, Amazon is investigating and investing in building strategies that increase energy efficiency, prioritize carbon-free energy, use lower carbon construction materials, and reduce water consumption and waste generation. DII5, then, is much more than a single node in a global network of fulfillment centers, delivery stations, office buildings, data centers, grocery stores, and entertainment venues. It builds on how Amazon thinks about all of its buildings and its operations, and serves as one more tool for learning more about how to make a difference. Mallory says the company will track the performance of the building and implement successful features in other Amazon buildings. We're tracking multiple metrics, including total embodied carbon reduction compared to conventional construction, operational energy efficiency, water conservation performance, impacts of biodiversity, etc. He said, we're also studying how the building performs in various weather conditions and monitoring construction and operational costs to assess the business case for scaling these approaches. While we view DII5 as a strategic investment in designing and implementing sustainability strategies in our future building design, it will also give us an opportunity to test which of these initiatives can be scaled across our existing buildings portfolio. If certain features don't perform as expected or can't be implemented in certain existing facilities, that information will be valuable in refining our approach to our future sustainable building design.